Our vendor presentation tonight is Aspen Modeling Company, and Pete Smith is going to make an introduction.
Thanks, Russ, and good evening, everyone. Yes, our vendor this month is Alan Anderson. He's the co-owner of Aspen Model Company along with his brother Lyle. Alan resides in Urbana, Illinois, and his brother lives in St. Louis. Alan is a University of Illinois graduate with a degree in finance. He started to work on a master's in computer science, but started working and never finished school. He spent the next 30 years as a computer programmer. His first love is military modeling, tanks, airplanes, and figures. He got involved in railroading through painting figures for Lyle. After seeing the quality of figures Lyle was working with, he said, "I think we can do better." And so they formed Aspen Modeling Company around 2006. Lyle comes up with most of the ideas and the references for the figures and goes to most of the shows. Alan handles most of the production, and both are involved in shipping figures all over the world. Alan will share the creative process with us and explain how they've evolved from artist sculptures and metal casting to scanning and printing. By the way, we are for the first time trying a video with this in this process that worked real well during the dry run, and we hope it shows well during this production. If you don't see Alan, it's because he does not have a camera on his computer. Okay, with that, Alan, I turn it over to you, sir.
Thanks very much, Pete. Yeah, like Pete said, we started this back in the early 2000s. Initially, we did our figures the old-fashioned way. They were made by an artist with sculpting material, and then they were cast in metal. We soon got tired of lugging around 50 pounds of metal when we went to conventions, so then we switched to doing them in resin, and that took care of the problem with the weight. But casting still has problems with seam lines, and it is kind of, when you get an artist, they try to make things as flat as possible, so you really don't get natural pose. So then 5 or 6 years ago, I said, okay, let's switch and go to 3D printing. 3D printing has many advantages to it. Instead of paying an artist to do an original figure in each scale, you can have them do it once, and then we can scale it up to as far as it needs to go. So it saves us a lot of money, saves us a lot of time. I do all the 3D printing of the figures, so we don't have to have an outside vendor do that for us. So the 3D scanners that we use are made by Artec. The one that we use most often is the Artec Eva. They also make another one, which we have, which is called the Space Spider, and it's for really small things. When you're scanning, you have to be about 5 or 6 inches away from the object, and it's really high quality. As it says on the screen there, it captures about 15 frames per second. It provides an accuracy, they say, up to 0.1 millimeters. And when you're scanning, you're essentially painting the object with the scanner. You must rotate and position it to get all the angles. Depending on the object you're doing, it can be very difficult to do. So I'll show you an example here of scanning an old-fashioned drill press. And it also makes a big difference the computer you use for it. Right now I'm using a pretty powerful laptop. Previously I was using a Microsoft Surface Pad. It was serviceable, but it only scanned at 8 or 9 frames per second. So like I say, you're essentially painting it with the light of the scanner. And this is really a pretty easy object to be scanning. It's, as you can see in the frame there, I'm looking at the computer and not at the thing I'm scanning. And I'll show you after this video of what I'm looking at on the screen. The distance away from the object is very important. It's kind of like a camera with a fixed focus. If you get too far away, you'll lose definition. Of course, if you get too close, you'll be out of focus as well. It's really amazing how accurate these things can be. I've scanned things as small as a spoon and I've had the spoon print out in HO scale, which is unbelievable. You really can't see it without a microscope, without a magnifying glass, but it's actually there. The biggest thing I think I've scanned to date is an F-16. So, and I've done all kinds of tanks. That's my main area of interest. And depending on what you're doing, scanning can take either very few scans. I scanned this a total of 2 times. But of course you get something like an F-16 or some tanks and stuff. And I have scans that are 100 or more, and to process them even on a fast computer, and I just bought practically the fastest computer I could get 6 months ago, to do some of that big stuff, to stitch everything together can still take overnight, and it's not even done yet. So it can take 12 or 14 hours for it to come up with a model. So we're about done with this, and then I'll show you what I've been looking at on the screen.
Okay, yep, we see it.
So as you can see, the object you're scanning starts to appear as you move around. Areas that, of course, are blank yet will still appear as white. I don't know if you can see it on your side, but the color of the object is green right now, which means I'm at the correct distance away from it. And on the bars on the left there, you want to try to keep it in the middle. That's where the green area is. And if you get too far away, it's blue. You get too close, it turns yellow or orange. And so this gives you a good idea of what you're missing and where you need to go. As you can see, maybe I put newspapers under the object because if you just use a blank background, it is more difficult for the scanner to pick up where it's at. So the more things you have for it to look at, the better. And you probably can't see it in this, but I have lifted the drill off of the surface of the table with some little blocks underneath. And that helps it when I go to remove the base, it will be much easier for it to do. Let me go back to my PowerPoint here for a second. And so this is what, this is hard to switch back and forth. Pete said they had problems doing it from the PowerPoint stuff, so I've tried to keep it separate, but makes it more difficult to go back and forth here. Okay, so here's what, after you get done scanning your item, you go into post-processing, and it's a program created by Artec Studio. Here I'm eliminating the base. As I was saying, you just sketch out on it and it'll put the base in red, and then you delete it. There's a lot of kind of extraneous stuff left over, but that'll be cleaned up here shortly. I could leave that and not actually clean it up, but the other post-processing, creating a final model will take a lot more time if you don't clean it up. So now I'm going to go into what they call autopilot, and the software will automatically clean it up and create the final model. I'm skipping the editing because I've already done that. It does something called global registration. I don't know what the exact process is, but it kind of puts everything back into proper positions. Some things could be a little bit out of position. And I sped that up a little bit because it usually takes, this one took about 2 or 3 minutes to do. So you can see it got rid of all the extraneous stuff. There's still some areas that I did not get. Can you see my cursor? That little blob there needs to be rescanned. There's some blobs there along the base. And as you'll see, of course, the bottom was completely undone. So it's just making a guess of what it should be. Change the color on it so you can see it better. So there you can see the bottom. So we have to add another scan to this to get a better representation. So here's a second scan that I've added. And so now we will stitch the two scans together. We'll erase the base again on the other one. I laid it on its side so we can scan the bottom. And I think this time I don't clean it up. So now I'm going to align the two together. So you have to position it and find some common spots on both of these scans. And then the software will merge them together. Here it kind of looks like there's a bottom to the blue one, but there's actually not. It's just sides to it. There's no actual bottom. It's best to always have at least 3 points that you're doing to triangulate it, so it's easier for it to position it. If you just do 2, it almost never comes out correctly. So there I was able to align them. So now I'll go back to autopilot. And when you're doing the autopilot, I don't know, you probably didn't see it, but you have a choice of making the final object watertight or not. And this one I did it watertight. Makes it easier to see where your errors are at and where you need to scan it. When you go to print it, if it's not watertight, you'll get an error before you can actually print it. So there we have a clean bottom. I'd say we're 80–90% of the way towards being ready to print, and did all that with 2 scans. And there it is. This one, when we actually do it and produce it, those parts where the drill press rotates, we might have to do those in photo etch metal because they'll be so thin when we go to print them. may not come out. So to give you an example of what happens after the model is created, I'm switching to something simpler than what that was. We've already done these dogs before. One thing I didn't mention, that with most objects, if possible, we hollow them out because the resin used to print these things is ungodly expensive. So we try to conserve on that, but it also makes it easier to print because if you have a flat area that is relatively big, when you're printing it, it likes to stick to the, they call it FEM or FPM, and it can mess up your print. So when you have it hollow, there's less surface area as the thing is being printed, and you'll see some of that later on. So this is the program where we add supports and position the models for printing. With the dogs here, it's lucky because we can just print them right on the surface of the build table. We don't have to have any supports for it. When you're doing this, you want to minimize the number of supports and make them as small as possible, because when you break them off, they will leave a little divot in the object that you're creating. So here I'm adding a point on the jowls or whatever of the dog, because I don't know if you can see, there's a line here that shows it's horizontal parallel to the base. And so as you're printing, this goes up, and when it gets to here, it shows you that this is lower and it's not attached to the rest of the dog. So you have to create a support for it. So when it gets to that area, it'll start printing here. And then as you go higher, it'll spread out and then become attached to the dog. So like I say, the supports, you try to keep them as small and as few as possible. And then of course you can change them. The points that attach to the objects, I try to keep it like 0.2 millimeters or less. Has to be a pretty big object to go any bigger than that. So here I'm showing you can go in and you can change this stuff. So I'm making this one bigger. Right now I had 0.15 millimeters. So I doubled it to 0.3. Made the radius of the mid part bigger. You can run into problems if you do it too small. Your object will not print correctly, and that creates a big mess, because then you have pieces of your object within the resin when you get done printing, and you have to strain the resin, and the resin is a pain in the butt to begin with, and it gets everywhere. It's a big mess. And then, of course, the base of the supports is an important thing, too, because there, again, it has to be big enough to not get damaged in the printing process. So the base usually has to be about 2 millimeters. And it's also good to cross the supports like that to give them extra strength. It's much more stable than just having two big poles sticking up. So this is the actual, I've done all the different scales here, 20.3, S, O, and HO. Going to print them all at once here. The yellow areas in this program show under areas that you might need to support. I've added some more supports here for the, especially the 20.3, because if you don't, it's surprising. It'll get a little bit wobbly, and your print will have wavy lines in it, or could possibly fail. So it needed some extra support. It'll show you here the slicing. When it's printing, I didn't check for this one. Maybe we'll see it when I actually go to print it. But it's actually made up of thousands of lines. So as you see it there, it's telling you how the progression is going to be as it prints. So now it's ready to go to the printer. This guy had a good video on how things are actually printed. So I included it in here. Let me know if I need to turn up the volume. That's the biggest, loudest I can go.
Okay.
Proximity to the FEP.
That's better.
At that point, UV light is projected in a specified pattern, and when this occurs, the resin hardens, sandwiched between the build plate and the FEP. The thickness of this print is very thin, typically around 1/20th of a millimeter. The UV light then turns off and the build plate pulls away steadily. As it does, the print peels from the FEP and remains fixed on the build plate. If you listen carefully during the printing process, you can often hear this as a small tapping or ripping sound, which is perfectly normal. One layer has now been printed, and it may have only taken a few seconds. However, prints typically require hundreds or even thousands of layers, each printed on top of the last. The size of the layer doesn't matter. It takes the same amount of time to print a layer this size as it does to print a layer this size, which makes resin printing a relatively fast process. For the second layer, the build plate once again descends, but this time not quite as far. The UV light fires, the resin hardens, and the second layer bonds to the first one and is completed. And so the process repeats again. Over a period of time, the prints build in layers, rising from the resin tray fixed firmly to the build plate. With the majority of printers, the print is formed upside down, hanging in place and dripping resin into the tray below. So gravity is always trying to pull the print from the plate. There's also a small amount of suction tugging on the print each time it rises from the FEP. But if the print is supported properly and the build plate is nice and level, it survives these forces and creates a successful print. But if the print isn't properly supported, or if the build plate isn't correctly fitted and leveled, the print fails, becoming an ugly blob on the FEP. Once complete, the build plate is removed and the print is freed from it. It's then cleaned, often in an alcohol-based solution, to remove any uncured resin. Finally, it's set with an exposure of more UV light. And that, in a nutshell, is that.
So here is the printer that I use. I couldn't really show you it printing because it's inside this enclosed area. So we printed these dogs, one of each scale. The print plate here, I think, is 2 inches by 5 inches, and it can be 6 inches tall. Sorry about the bad focus there. So there they are. At this point, they're still covered in resin. And like the other guy said, they need to be cleaned. So I will clean them in an ultrasonic cleaner in 90, I think it's 90% isopropyl alcohol. And I'll do it until it comes out of the ultrasonic cleaner and the alcohol is still clear. So now I'll take them off the build plate there and dump them in the alcohol. The problem with the hollow figures is, depending on how big the hole is, sometimes the hole you make is only 1 millimeter or 2 across. And you can see the paper towels there. I have to roll up the paper towel and stick it into voids to try to get out the resin, which did not come out of the figure while I was printing. And you don't want to have that left in there because the UV machine can only penetrate, I forget what it is, 1 millimeter or 1.5 millimeters. And it's just being put in water there, the ultrasonic cleaner, put the weight on top so it doesn't come out. I do it for 3 minutes at a time. So this is after the first 3 minutes, and you can see how green the alcohol is. So definitely need to do this another time. And I reuse this alcohol. I spend a fortune in alcohol. If you let it sit long enough, the excess resin will settle to the bottom and you can get a pretty clean pour. So this one was really, really dirty, probably because of the big dog. He's got a lot of, you can see the green streak on the cup there. He's still got a lot of resin inside of him. And there I'm trying to get the air bubble out so that the dog doesn't float. I want him to be filled with the alcohol so he gets cleaned out. Here's the second time. We're getting closer. It's a little bit clearer. There's the third time. That looks really good. So they have not been put through the UV machine at this point though, but they're clean of the resin now. I've got a UV machine and it's a small machine. It's only maybe 3 inches by 3 inches. I put them in there for about 8 minutes and then they are cured hard. At this point, they're still kind of sticky. And you don't have to use a UV machine. You could probably just set them out in the sunlight. I'm guessing it would maybe do just as well. So that's the process of making a 3D figure. Any questions?
Hey, fascinating, Alan. Thank you very much. I can't believe how involved the process is. Let me go down the list of questions. Steve Hollenbeck says, is that an auger for pre-drilling bridge timbers?
I doubt it. It maybe on a layout you could do. It'd probably too big for the layout though. You'd have to be a 20.3 layout to do anything like that. It's
Okay.
amazing the old tools that I've been scanning or whatever, how innovative they were to get it done.
Interesting. Robin Peel says, is it scanning with visible light, LiDAR, or something else?
It actually, I think it puts a grid on what it's scanning. And I'm not sure if it's like a radar that can read back how far away it is on the grid. I mean, the grid will distort based upon the shape. So I'm not sure exactly how that works.
Okay. Tom O'Hara answers the previous question. It's for a kind of timber construction, including posts, beam barns, and bridges, etc. Don Formack says, when you show the scale as G, what is the actual scale?
20.3.
Okay. One. Rod Jensen, can you produce more seated engineers besides 0-74 and maybe a fireman in O scale like S78 fireman, 1930s hats and clothing preferred?
Yep. Those are in the works.
Okay, great. And finally, Keith Stamper says, if you have to produce multiple figures, say a few hundred, do you have to go through the same process of washing individually?
Yes, unfortunately. Yep. Like on the HO dogs, just to
Mhm.
give you an idea. Like I said, the build area is maybe 5 by 2 inches. I think I can fit 50 HO dogs on that and print 50 at one time.
Oh, okay.
But it
And
takes me way longer to clean them up than it does to actually print them.
Yeah, I bet. So how long does it take to print a S scale dog, for instance?
Probably only
Or-
about an hour to do the 20.3. He's the one that took the longest time. It took about 2 hours and 15 minutes, I think, to do the 4 of them. But the big dog was the one that took the time.
Interesting. It just as a casual observation, it would seem that this process of printing for 3D printing is very involved, and I don't see why it's more productive than spin casting. I understand the weight problem, but it would seem to be a lot faster to spin cast.
Right. Well, the thing is here, when we were doing them with the artist doing the clay figures or whatever,
Mm-hmm.
then of course you have to pay 3 times for the original, or 4 times if you're doing all 4 scales.
Okay,
And
that's
that,
true.
yeah, that gets way expensive.
God, okay. Well, listen, thank you very much for that presentation. That was very informative, Alan. Thanks a lot for participating.
Yeah, I'm glad to do it. Sorry we had so much trouble at the beginning, but
Not a problem.